In this video, I'm going to explain taper turning cycle. Now, before going to see the how to write the part program, now it looks like the taper turning. Here there is a two types of taper turning. One is the negative taper turning, and second one is the positive taper turning. So based on the dimensions, the difference of radius values, its negative is coming, then it's a negative taper turning. If it is positive is coming, then it's a positive taper turning. That we'll see one by one. First we'll see that negative taper turning cycle. Now for each mission there is a reference point. Okay, now let us see that for this also there is a reference point RP, and the tool initially it will be there at a reference point. From the reference point, the tool will come to the tool entry point. The tool entry point is defined slightly above the workpiece and in front of the workpiece. Now here defined the point 1 is the tool entry point. Now the tool is moving from the reference point to the tool entry point. Now the cutting takes place, how the tool is moving, that will be explained here. Now define the second point, the point 2. Now the tool is moving from point 1 to 2 in downward direction. Then from 2 to 3 according to the taper defined, the point 3 is assigned. Now the tool is moving from point 2 to point 3. Again the point 4 is above. So from 3 to 4 the tool is moving up, and from 4 to initial point 1 the tool is coming in horizontal direction. So this is the path of the tool is how is moving, that is explained in this slide. Now let us see that what is the syntax we are used for taper turning. Like our plane turning, here also G90 is used for the taper turning. G90, X, Z and RF. Here only the addition is R value. So the R value is the addition compared to the plane turning cycle. Now let us see that individual what are these components. X indicate the diameter to which the movement is being made, and the value, the incremental distance from the current tool position to the required final diameter, that we had to mention within the bracket of X. And Z, the Z axis coordinate to which the movement is being made, and the W value is the incremental distance from the current tool position to the required Z axis position, that you can mention within the brackets. And R, here R is the difference in incremental of the cut start radius value and the cut finish radius value. The difference of starting radius value and ending radius value, that is the R value. So based on the diameters, it may be coming negative and it may be positive. Both the tapers are possible using the same syntax. And F indicates the feed rate. The feed rate we are assigning based on the tool material and workpiece material, surface fins required. Those parameters based on we can decide what is the feed rate. Now once again you can see that how the tool is moving. Simulation I want to show that now the tool is entered from the reference point to the tool entry point, and from the tool entry point to the second point the tool is moving like this, and from 2 to 3 the tool is moving like this, and from 3 it's lifted up 3 to 4, then again it go back to the initial position. Then after finishing the entire taper turning operations, then the tool will send to the reference point at the final. Okay, this is the way the tool is moving. I hope everyone understand how the taper turning is taking. Now let us take an example problem and write the program. Now let us look at this example problem. Here the diameter is 35 mm and the plane turning is 30 and taper is the length of 15. At one end the diameter is 0 and other end the diameter is 35. So that is the taper is given. Now you can see that initially this N10, G21, G98, that is the block G20 metric units, G98 the revolutions per minute. Then it goes to the home position, that is the G28 U0 W0. Go to the home position, the tool will send to the home position. Then you can select the tool for which operation you want accordingly the tool. Here now the tool is T02 and M06 indicates the change of the tool. Then after changing the tool, now we can set the spindle speed and start rotating the spindle in clockwise direction. That is S900 M03. Then the tool will enter from the reference point to the tool entry point. So this movement is a rapid movement. Then we are assigning the G00 and X35 Z1. Okay. Just exactly on the top of the workpiece, just 1 mm in front of the workpiece, the tool will come and it will stay. That is the point 1. Next, the tool is moving from point 1 to point 2. Point 1 to point 2. So that is a G90 X35 Z minus 15 R not F60. Here you can find out the R, the radius value. That is the entry radius value minus exit radius value. And that you have to find out the R. That R is equal to, here entry radius value is 0 and exit radius value is 17.5. So it is a minus 17.5. So now at a time that entire material, it's difficult to remove it, then we have to remove the stepwise. Okay, now we take the R value, different steps, and you have to complete the entire material. So now this is because of that negative sign is coming, we can call it as a negative taper turning sign. So now we can use that this N40 R minus 4. First R0, then R minus 4. Or minus 8. Now each time that is I taken the radius of the 4 mm. Okay, so that 8 minus 12 minus 16 and final is a 17.5. So that is a minus 17.5. So here I am using these steps 1, 2, 3, 4, 5 steps. Within 5 steps the entire material is removed from right side, it's coming to the 0, and the left side is as it is 35 mm diameter. That taper is machining is taking place, and after machining, then the tool will send to the home position, that G28 U0 W0. Then the spindle stop. So M05 the spindle stop. Then M30 program and rewind. These are the steps. According to these steps, the taper turning operation will be carried out. I hope everyone understand how you can write the part program for taper turning cycle, especially for the negative taper turning cycle. The next video I will explain the positive taper turning cycle.